Let's focus on a more complicated example now with redistribution, and you will see why it's so important that you really understand what happens with the redistribution process and how administrative distance comes into play and metrics comes into play and the ramifications or the consequences that can result by not fully understanding complex redistribution scenarios. So our example focuses on just a redistribution of a static default route on R2. So this static default route is redistributed using the redistributed static command in the EIGRP configuration mode. And what's going to happen is it's going to be sent to the neighbors. And both of these neighbors here, R1 and R2, are going to see that the static default route is reachable via R2, and the administrative distance is 170. And it's 170 because it's external EIGRP learned route. That's what it is because of that redistribution process. So everything's fine right now. There's really not a problem. R1 is going to install in its routing table the static default route pointing to R2, and R4 is going to install the static default route pointing to R2 as well. However, we are performing redistribution on R1. And since we're performing redistribution on R1 and R4, that static default route is going to be redistributed into the OSPF process. And we want that to happen because we want R3 to be able to reach the internet as well. So now we are redistributing at these 2 points. And we're going to follow the arrows here. We're going to follow the green arrow from R1. And then we're going to follow the purple arrows from R4. And these arrows are representing our LSAs that are coming from R1 and R4. And when the LSA from R4 arrives at R1, R1 is receiving a Type 5 LSA. It's an external route from R4. And what does it say? Well, it's going to say that by default we are dealing with an E2 route in this particular case because it's Type 5. We haven't modified that at all at the redistribution point, but we could. And it's 0.0.0.0/0 reachable via R4, and the AD is 110. When we look at the LSAs that are coming from R1 and ending up at R2 and R4, we're going to see that they're E2s, 0.0.0.0/0 via R4, R1 with an AD of 110. So notice how I'm saying R4 and R1 because those type 5 LSAs, they point to the autonomous system boundary router. That's the advertising router. So based on the type 1 LSAs that are being flooded around our OSPF area, then R1 and R4 know how to reach each other in order to do those routes. But that's not the problem here. Oh, this is fine. This is great. The problem is now R1 has to make a decision. Do I use this OSPF learned route for 0.0.0/0, or do I learn the external EIGRP learned route of 170? Oh, yeah, now that's the problem, isn't it? Because R1 is now going to choose that OSPF learned route. And it removes the EIGRP route from the routing table and puts that OSPF route in. R4 does the exact same. It chooses the OSPF route at 110 for the administrative distance versus the EIGRP route at 170. So now R4 and R1 are pointing to each other to reach the internet through the OSPF domain. Yeah, that's not going to happen, right? Nobody's going to get to the internet here. So this is just a small issue, folks. Well, okay, it's bigger than small because the network's not working. But what else could happen here? Well, think about how redistribution works. Redistribution works by taking information in the routing table and redistributing it. R1 and R4 had redistributed the EIGRP routes into the OSPF domain. Are the EIGRP routes in the topology table? Are the EIGRP learned routes in the routing table anymore? No, it's the OSPF routes that are in the routing table, which means that R1 and R4 can no longer redistribute those routes into OSPF, meaning that R4 has to tell R1 and R1 has to tell R4 that those routes no longer exist. That static default route doesn't exist anymore because it's not being redistributed. So they tell each other that it doesn't exist, so they remove that route from the routing table, from their link state database, and then they reinstall the EIGRP learned route from R2 into their topology table, and then what do? They redistribute it back into OSPF, and R1 and R4 point back at each other. And then they realize that they can no longer redistribute it again, and you see the problem we're having now? For a split second, everything's fine. After that, everything doesn't work. For a split second, things are fine. Things don't work. Wow. Wow. This is a disaster. This is awful, folks. Awful. Let's look at a solution as to how we can fix this.